the previous video, we discovered that the modules of Hapta 67 are securely bound internally through the post-tensioning method, and we explored how the connections and bonding between modules were established. Additionally, we confirmed the use of high-strength grout and sealant in the finishing work, along with asphalt coating around the junction areas. In this video, we will explore waterproofing and windproofing for exterior walls, finishes for interfaces between modules, and finishes for the upper surface of the lower module, which serves as the terrace for the upper module. We will also look into methods and devices used to align modules horizontally and vertically during stacking, as well as devices used to verify alignment. Additionally, we will describe the MEP system within each individual module and its integration with the overall MEP system of Hapta 67. In the previous video, we briefly explored the methods used in Hapta 67 to overcome water leakage, including the application of such as asphalt coating and sealant. Today, we will use modeling to divide the areas and examine how the final finishes and joints were achieved in each section. We will look into Section A, where each module contacts the exterior, Section B, where modules connect with each other, and Section C, which concerns the terrace area. First, let's take a look at Section A. Section A is where the modules are directly exposed to the external environment. In the original Hapta 67, the walls had minimal insulation, leading to durability issues and leaks over the years. Additionally, the ability to block external air was inadequate, making it vulnerable to the harsh Canadian winters. These weaknesses were addressed in a major renovation in 2017. The existing concrete walls were stripped back and cleaned, removing some damaged wood and the old polystyrene insulation. 31mm liquid air and water barrier was applied. The barrier stops water and air penetration, but does not impair the movement of vapor. A Z-guard system was installed against the wall and insulation was added. Smart vapor retarder to allow the wall to dry either toward the inside or the outside, depending on the direction of the water vapor flow, which is directed by temperature and or water vapor pressures. The Z-guard system is a specialized exterior cladding system applied to the outer walls of buildings. It typically involves covering the exterior walls with a mixture of cement and gravel, known as gart, enhancing the building's protection from external elements and increasing its durability. The Z-guard system helps improve the robustness and longevity of the building envelope, safeguarding it against wear and tear over time, and providing protection from weathering and climatic changes. Ultimately, to control airflow and vapor drive, increase drying potential, and prevent moisture-related issues while better preserving the building envelope. The renovation approach described above was applied to Hapta 67. Next, let's examine Section B. Section B represents the area where modules meet each other, and most crucial finishing detail in this area is the perimeter. In this perimeter area, besides the sealant and asphalt coating mentioned in the previous video, protective mortar was applied to maintain integrity. Lastly, let's examine Section C, the terrace area. Each unit in Hapta 67 has at least one terrace, which is an important space. The primary concern here is how to properly drain water from the terrace. Without an adequate drainage system or proper finishing, maintaining the terrace would be difficult, especially during rain or when watering plants. First, let's look at the drainage system. The terrace is slightly sloped to direct water to a drain located at the corner of the terrace. This water flows into the MEP system pipes within the module, which will be explained at the end of today's video, and ultimately into the overall MEP system of Hapta 67. Terraces located on the 4th, 8th, and 12th floors drain directly into the Hapta 67's overall MEP system without passing through the module's MEP system pipes. Next is the terrace finishing. The terrace's finishing begins with the installation of the roof, which forms the terrace itself on top of the module. The module that serves as the terrace's railing is then installed. Sealant is applied at the junction between the railing and the terrace to ensure a proper finish. Finally, the terrace floor is covered with treated wood for easier maintenance. Treated wood is advantaged because it is easy to replace if damaged and has a relatively short installation period. In the next video, we will delve more deeply into MEP systems and the HVAC system discussed today.